Welcome to SolidCAM Professor. I'm Sydney, your SolidCAM Professor, with one of many videos available to you 24 hours a day, 7 days a week. In this recording, we'll demonstrate the use of several HSM operations to machine this mold insert. We'll first start off with the HSR operation to rough out the material, and if we go into the operation itself, we'll be using the HSM roughing option of HSR. The tool in this particular case will be a rather large tool, a 20 millimeter in diameter end mill. The passes, you'll note, that will be leaving 0.3 millimeters on the wall and floor of the part, and will be going down every 5 millimeters. In other words, we'll be having pretty large steps. In addition to that, we'll be working with the technology of step over type of HM spiral, which is actually allow us to work from the outside of the part. If we take a look at the simulation, you'll see the following. The tool will be working from the outside of the part, machining exactly the way we want it to, from one side to the next, always from the outside on the part. Now in our next operation, we'll be doing a rest rough operation to clear off these large steps that we've created here, plus allowing it also to go into areas where this tool was not able to go in by using a smaller end mill. So if we go into that actual operation, you'll see that we're using the option of rest roughing. The tool in this particular case will be a 12 millimeter ball nose end mill. And if we go into our passes, you'll see we'll still be keeping the same wall and floor offset. However, our step down this time is every 2 millimeters instead of 5 millimeters. This way it will clear off those steps, making them into smaller steps, making it easier to work on when we're doing our semi-finish and finish operations. Let's take a quick look at the simulation itself, and you'll see that this time the tool is working only in those areas and making the steps smaller as it goes down the part, and they're only working on the stepped areas. As you can see, as it's going down now over here, and you saw also that it worked in this area where the previous end mill was not able to go into. Now in our next operation, we'll be doing a semi-finish to take off the material that we have here and getting it as close as possible to the actual finish, allowing for the finish to actually give a much smoother finish to the part, and also taking off a lot of the pressure that you may have on the actual finish tool. So if I were to go into the operation, first you'll see that I'll be using the option of linear machining, and I've also used the apply fillet option that we don't have any sharp corners as the tool path goes into the corners. The tool in this particular case will be a 10 millimeter ball end mill. Let's go into the passes. In the passes, you'll note that our wall offset is set at 0.1 millimeters, getting it ready for the finish cut. And our step over will be every 2 millimeters. Let's take a look at the simulation, and you see that the tool pass goes across in a linear fashion, and you can also note that in these corners over here we have a radius on the tool pass. This is because we did an applied fillet, allowing the tool, which has a larger fillet in the corner over here, to actually do a fillet move instead of having a sharp turn into the actual material itself. Now in the next operation, we'll be doing again a semi-finish rest machining for these corners. And if we go into the operation itself, you'll see we'll be using the option of rest machining. The tool will be a 6 millimeter ball end mill, and the reference tool will be set at 12 millimeters. This way it controls exactly where we want to have that tool work. If we go into our passes, since we're doing the semi-finish, we will still be working with a wall offset and a floor offset of 0.1 millimeters. If we were to take a look at the simulation, you'll see that the tool pass is being created just in those areas, and it's getting, since it's doing a semi-finish, it's getting it ready for the finish operation, making it easier also later on for the finish operation to remove the material that's left over there. Now, the rest of the operations that I will be doing will all be finish operations. So first, let's start off with the linear operation that I've done over here. And again, I'll be using an applied fillet so that the tool will always work on a radius when it gets into the corners. The tool itself will be a 6mm ball end mill. And if we take a look at our constraint boundaries, this time we'll be working only in this area on the part itself, between this and the actual core itself. The core will be doing in a different operation. The passes, you'll note that the wall offset is set at 0. That means we'll be doing a finish cut. And we have a step over of 0.2 millimeters, allowing for a nice, smooth operation. If we take a look at the simulation, you'll see that the tool pass working only in those areas in a linear fashion, going back and forth. And when it gets to the area where we have the core, it'll actually work around the core itself, exactly up until the borders of that part, and giving for a really nice smooth finish, since we did a 0.2 millimeter step over on the part itself as it completes now the entire part towards the very, very end. Now in the next operation, we'll be doing a combined constant Z with a linear to complete this area over here. So if I were to open up the operation, you'll see we're doing combined constant Z with linear machining. Again, as far as our geometry goes, we've added the option of apply fillet to allow for corners to be milled with a radius fillet over there automatically. The tool, again, will be the 6mm ball end mill. And in this particular case, the constraint boundaries is only this area in here. Now, if we go into our constant Z passes, you'll see we have the wall and floor offset set at 0 for the finish. And we've limited our working angle anywhere between 35 and 90 degrees, as we only want to work with the constant Z in the steep areas. In our linear passes, we'll be working from 0 to 38 degrees, giving for a 3-degree overlap. And one more thing should be also noted, that we've defined the angle of our working direction so that it works in this direction along the part when it works linear. Let's take a look at the simulation, and what you'll see is as follows. It starts off by doing the constant Z, only working on the steep areas. And you can also note that when it works in these steep areas and when it gets to the corners, there's an actual fillet there, and that's because we use the option of applied fillet. Now, when it finishes those areas over there, it'll then start the linear option. But it's first doing the constant Z. Note, skipping over this area, which is actually a flatter area, but working around those areas until it gets to the very bottom of the part. And once it finishes that, as I said before, it'll start doing the linear cuts. Again, you can see that it skipped over this area because that's a flatter area meant for linear machining. And now it's going to start working linear. As you see, linear back and forth in this direction, the same thing as it goes up on the part, completing that area until it gets to the very end. Now, in the next operation, I'd like to do the rest machining on these corners over here, as well as these areas over here. In other words, all the corners I'd like to do now using the rest machining. So if I were to go into rest machining, I've used the tool of 4mm, a 4mm ball end mill, and the reference tool in this particular case was 8.2 millimeters, which actually controls the area where the 4mm ball end mill will actually work. If we take a look at the simulation, you'll see that the end mill will work exactly on all of those radiuses on the entire part, including on top, inside over here, as you'll see in a moment, completing all those corners. Now, there's still one area where I'd like to make a little nicer of a finish, and that's this area over here, as well as the one on the other side. So for that, we've gone and used a different operation in HSM called 3D constant step over. In this particular case, we will be using the 4mm ball end mill, and if we take a look at our drive boundaries, we will be working only in these areas. If we look at it from the top view, only inside those areas. Those are the drive boundaries, and that's the shape it'll actually work in. And the constraint boundaries is the exact same area, only working within those areas. If we take a look at the actual simulation, you'll see that the toolpath works exactly in those areas with a constant step over, making for a really nice smooth finish on this side as well as the flip side over here, finishing now the entire part. For more videos on SolidCAM Professor, please go to our website www.solidcam.com and look for our Professor tab. Take care and have a nice day.